So hello everyone. In our previous lecture, we had completed the topic of optics. In this lecture, we are going to discuss about the fluid mechanism and waves and oscillations. Okay. So now let's start. So the first is fluid. The first is fluid. So basically, to justify any substance as a fluid or to get a meaning what do you mean by fluid, we require three conditions. First condition is non-resistant. Second condition is easy flow. Third condition is would be taken any shape. Got it? If any substance justifying these three conditions, like the condition of being non-resistant, condition of easy flow, and condition of could be taken any shape, then the substance will be considered as a fluid. Got it? And basically, whenever we are discussing about the substance, we always considering solid, liquid, and gas. Solid, liquid, and gas. Got it? So let's understand them by one. Okay. So the first is a solid. So basically, if we taken the three conditions in the control, if we taken the three conditions into consideration, then the first is solid is resistant. Second is no easy flow. And third is would not taken any shape. Okay. So here we have come to know about that the solid is resistant, solid could not be easily flow, and solid could not taken any shape. So all the three conditions are getting denied in case of the solid. So solid is not fluid. Got it? Now let's take another example of liquid. So first, second, third. First is liquid is non-resistant. Okay. Second is liquid having a easy flow. And third is would be taken any shape. So in case of liquid, all the three conditions are fulfilled. So you can say liquid is a fluid. Got it? Now take an example of another one, which was the gases. 1, 2, 3. It is highly non-resistant. Second is high easy flow. Third is could be taken any shape, or you can say or almost no shape. So in the case of gases, all the three conditions are getting matched. Okay, and even higher match. Got it? So we can say gases are also the fluids. Got it? So basically here we have discussed the fluid is a substance that can flow and adapt to any shape of its container or you can say any container or any object when it is getting filling into it. It is getting filling into it, okay, including liquids and gases, because solid is not fulfilling these conditions. Got it? Now let's move forward. Like the first example is water. Water is an example of fluid. When you pour water into a glass, it takes the shape of the glass. If you pour into the ball, a bottle takes the shape of that container. Okay, so let's change the example into action. So when this is the water having no shape, So if you pour it into the glass, it will take the shape of glass. Whereas if you pour it into the ball, it will take the shape of bowl. Got it? So water is an example of fluid. Okay. Fluid are important and special because they can flow and move around easily. Alright. And they having a different properties like the density, pressure and buoyancy, which we will discuss in this lecture. So let's start with the density. So what do you mean by the density? Density is like how closely packed the tiny particles, atoms and molecules are in a fluid. Heavier fluids have more closely packed particles and lighter fluids have less closely packed particles. Basically, you can say any object is made of atom. We will have a discussion of atom in a chemistry class. Till then, just remember, any object or every object is made of a atom, or atoms are basically the building blocks. Building blocks of the substance. Got it? If these are closely packed, the substance will be resistant. If they are loosely packed, substance will be non-resistant. Got it? So in the case of fluid, these particles are not so closely packed, so that's why the fluid is non-resistant. Fluid is non-resistant. Whereas in the case of solid, these are closely packed, so that's why solid is resistant. Got it? And even in the fluids, if this is a fluid A, where there is less space, whereas it is a fluid B when there is high space. Okay? So fluid A and fluid B, after them, fluid A will be less movable, whereas fluid B will be more movable. Got it? So here we have understood the density. Got it? Density is basically how the particles of an object combine together. If they having a more space between them, then they will be more resistant. If they have a less distance between them, they will be a. Now let's move forward. So the pressure. Pressure basically, the simple definition is force acting upon per unit of area. Okay, if this is an area and there is a force applied, then this area will be known as the pressure. Got it? So basically, pressure is the force acting upon the per unit area, or you can say pressure is like a gentle push that floats have on things around them. When you press your hand against the water in a swimming pool, you feel the water pushing back your hand. That's the pressure of the water. So basically, it's a definition of the pressure and how we could relate it with the fluids. So this is the proper way to relating this concept with the concept of fluids. Got it? And how We could take an example. Suppose this is a container. This is a container, and this container contains the fluid. This container contains the fluid inside it. Okay, so the walls of the container, these walls of the container, as well as the base of the container will be facing pressure, because these water particles will be applying pressure on the walls as well as the water. Got it? So this is the pressure acting upon this area, or you can say per unit of area. So here we have come to know about what is the pressure and how the liquid pushes the pressure at the walls of the container where it is kept. Got it? And even in the swimming pools, when you try to push water, similarly the water exerts pressure on your hand. Okay, like it is given here. When you press your hand against the water in swimming pool, you feel the water pushing back your hand because water exerts pressure also. Got it? Now come forward. Now this is the buoyancy. This concept is the buoyancy. It is the upward force exerted on an object immersed in a fluid opposing the gravitational force due to differences into pressure and density. Suppose this is an water. Whenever, like this is an object, whenever you will try to sinking this object into the water will apply force into upward direction. You are putting it to the downward direction. The water will apply force to the upward direction. And this force which is applied in the upward direction is known as force of buoyancy. Okay, opposing the gravitational pull, because gravity is always acting to the downward direction. Gravity is always the acting force of downward direction, but buoyancy is applying force to the upward direction. Got it? Due to differences in pressure and density. Got it? On this object and water, there is a difference between the pressure having the water and density having the water, and the pressure and density having the object. Got it? Now, Bernoullis principle. Basically, there is two types of flow. Like this is a pipeline. This is a pipeline. There are several points, point A, point B, point C, point D, and there is pipeline, point A, point B, point C, point D. There are two types of flow. One flow is streamline flow. Second is turbulent flow. Streamline flow and turbulent flow. Okay. So during the streamline flow, the flow of water will be equal at every point of the pipeline. The flow of liquid, or you can say the water, will be equal to the every point of the point line. Like at point A it is 10, point B it is 10, point C it is 10, point D is 10. It is 10. But in case of turbulent flow, the flow of liquid at every point will be different. At A it is 10, at B is 20, D it is 30, and at C it is 30, at D it is 40. So this scenario comes under the streamline flow, and this scenario comes under the turbulent flow. The streamline and the turbulent. Got it? So basically, Bernoullis theorem states that in inviscid flow of a fluid, an increase in its speed corresponds to the decrease in pressure and vice versa. Okay, in the streamline. So here I have explained you the streamline and turbulent. So basically when the flow is streamline, if the speed of liquid increases, then the pressure will be decreases. So there will be a negative relationship. Negative relationship between the speed of liquid and the pressure. Got it? And similarly, if the pressure increases, then the speed of liquid will be decreases. Got it? So it was the Bernoullis principle. Now let's take an example. Imagine you blow on a pinwheel or a paper airplane. It starts spinning offline. That's because your breath makes the air move faster around the pinwheel or the airplane. Alright. Now let's move forward. So here we have waves and oscillations. Here we have waves and oscillations. Okay. So here the question is, what do you mean by wave and what do you mean by oscillation? Basically, in simple terms, oscillation is coming back and forth direction. Coming back and forth direction. It is a simple definition of oscillation. Okay. So let's take an example. Suppose this is an object. This is a point. You push this object with force. This object will move to this point, but after some time it will move to this point again. Right? First, when you push it, it moves to this position, but after some time it will move to this position. So this is a motion of coming back and in fourth direction. Got it? And this is called the oscillation. Okay? This is called the oscillation. And oscillation generates wave. Oscillation generates wave, as you can see here. Got it? This is the wave, and this movement from this to this is a oscillation. Got it? Okay. So basically we can say in simple harmonic motion. And what do you mean by simple harmonic motion? Have you ever seen a pendulum watch? Have you ever seen the pendulum watch like this? These are the pendulum watch, and this is the pendulum. So what happens with this pendulum? This pendulums start moving in a wave format. In a wave format. From A, it goes to B, and from B, it's come back to the A, and then go to the C, and from C, it's come back to the A again. Okay, and this movement keeps happening in this pendulum watch, and this motion is called as the simple harmonic motion. repetitive back and forth movement around an equilibrium position where the restoring force is directly proportional to the displacement. Got it? So you can say the force required from moving the object from A to B or from A to C will be equal to getting object back from B to A and from C to A. Got it? So it was the simple harmonic motion. Okay, let's take another example. Suppose, imagine you are in a swing on a playground. Like you must have seen this type of swings in the playground. This type of swings in the playground where the person has to sit in the middle of the swing and then he could move forward and backward. Okay, forward and backward direction. Okay, so this back and forth motion is like a magical dance, and this is called the simple harmonic motion because at one place when the swing is at rest, it's a point A. When it pushes it in the fourth direction, it will be a point B. After some time, it will come back to the A and then will go to the point B in the backward direction, and from point C, we'll go to the point C in the backward direction, and from point C we'll come back to the point A. And remember, the force of displacement will be equal to force of restoration. Simply means the force you applied to go to the B will be equal to the force required to coming from B to A. Similarly, the force required to go from A to C will be equal to get a force will be equal to the force required come to A from the C. Okay, so this swing where you are doing this thing, like you are going forward and then you are going forward and then you are coming back to the position, and then you come backward and again coming back to the position. Got it? So this scenario is because of simple harmonic motion. Okay, now let's forward. A spring can also do this motion. Like if you ever seen a spring, this kind of spring, or basically you can say this kind of spring, stand like this. Okay, and there are so many spirals between them. So if you ever press this spring like in this format, then when you released it, or you can say when you withdraw the force from it, it will jump back as it was. This is also the example of simple harmonic motion. Got it? Now let's move forward. Is the wave equation. What do you mean by the wave equation? Basically, whatever we have learned, like the oscillations is the forward and backward motion. Oscillation is the back and forth motion. Then it generates the wave. Okay, and representing the wave in the mathematical expressions. For better understanding will be the oscillation. Expression will be the wave equation. Got it? It is basically relating to the second derivative of displacement with respect to time to the second derivative of displacement with respect to the space, or you can say if we have a pendulum like this, we shift it to the point B. Let me draw it here in the clear form. Like if we have pendulum like this at point A, if it's swing it to the point B, then it came back to the point A, then hereafter it goes to the point C, and then came back to the point A. Okay, so during this, how much space covered? Like distance between A to B, B to C, and also the coming back. Second is how much time taken. How much time is taken from going from A to B and coming from B to A, then going from A to C and coming from C to A. This all is represented by the wave equation. Got it? So example, imagine you have a speaking rope and you shake one hand up and down. As you shake it, you see a wave traveling from one end to the another wave. Okay, so this all is represented by the wave equation. So here we have finished the physics part. In our next lecture, we will start with the chemistry. Until then, thank you.